In this video, I want to show you how you can use the files you created in the previous videos to actually show that your lines are parallel and perpendicular, as well as the slope of your transversal line. So you could do this on paper and then take a picture of it, submit it that way. That's perfectly fine. Or you could, if you wish, submit a Google Docs. So I'm going to go to docs.google.com. And if I'm already logged into my HCDE account, which I am, then I should see a variety of things. I'm going to hit a new file. I'm going to call this 3D print slope calculations, or stamp calculations, whatever you like. And I already took a screenshot earlier of my graph, so I'm actually going to import that in. That way I can see it in front of me and I don't have to change windows all the time. So that's going to be this file right here, if I recall. Nope. There we go. So from your requirements, you need a couple of things, and they include the slope of a pair of parallels. So what I'm going to do is I'm going to say that the slope of AB. So to get the slope, I'm going to write an expression for the change in y over the change in x. So to do that, the best way on the computer here is to use the equation editor. So I'm going to hit Insert, Equation. And I just found out the font is really small, so I'm going to make that bigger and see if that actually works. Let's see if I can increase the size here. There we go. So I'm going to turn this to a fraction. I just typed something in random just to give me something to play with. And I need the slope, which is the change in y over the change in x. So the y value of point B looks like it's 3, and the y value of point A is negative 1. So I have 3 and negative 1 as my change in y. So 3 minus negative 1. And my change in x would be, let's see, from B my x value is also negative 3, and my x value for A is negative 4. So negative 3 minus negative 4. So that's going to give me another fraction here. There's only 3 plus 1, which is 4, and that's negative 3 plus 4, which is 4 minus 3, which is 1, which doesn't show up in the right place, which means the slope of AB is 1. Let's repeat for the lines that we think are parallel to it. So I'm going to say insert, say before that I'm going to move some spaces over here by hitting tab. Slope of what appears to be parallel, I believe, is CD. So insert equation, make a fraction for change in y over change in x. D's coordinates are negative 2, 2, so the y value there is 2, and the y value for C is negative 2. So that's 2 minus negative 2. And the x values of D and C respectively are negative 2 and negative 3. So that would be negative 2 minus negative 3. Subtracting a negative is equivalent to adding. So just like the last case, we have a slope of 2 plus 2 is 4. And 3 take away 2, when I change that to addition, I would get 1. So because these two slopes are the same number, these two lines therefore must be parallel. I also need to show that I have a pair of perpendicular lines, or a set of perpendiculars rather. So I already have AB slope, which I already have established here as 4. Let's take a look at a segment BE, which appears to be perpendicular to it. So I need the slope of BE as well. And if it's a certain pattern with the slope of AB, then I know that those two segments are perpendicular. So slope of BE, I'll shrink that a bit later on. Insert equation, I'm going to need a fraction. So B's coordinates, BE's coordinates, let's see, E has a y value of 2, and B has a y value of 3. So if I subtract those, I have 2 minus 3. And for the x coordinates, for E I have 1, and for B I have negative 3. So that'd be 1 take away negative 3. So simplifying this, 2 minus 3 will give me 1. Oops, make a fraction here. And actually that could be negative 1, won't it? 2 minus 3 is negative 1, and 1 take away negative 3 is 1 plus 3, which is 4. So the slope of BE is negative 1/4. And if I compare that to the slope of AB, which is the slope of positive 4 over positive 1, I'll notice that these two slopes are opposite reciprocals, and as such, these lines are indeed perpendicular to each other. So I have numerical evidence to justify that my slopes are perpendicular. One more calculation, which is to show that the slope of my transversal line is neither parallel nor perpendicular. My transversal, and I have a couple options here, I believe is CF. CF looks like it would cross both DF and CD. So let me see the slope of CF. Slope of CF, that would be another ratio of rise to run, or vertical change or horizontal change. F has a y value of 2, and sorry, of 1, and C has a y value of negative 2. So 2, so 1 take away negative 2. And for my x coordinates, I have 2 for F and negative 3 for C. So 2 take away negative 3. So that gives me 1 plus 2 is 3, and 2 plus 3 is, famously, 5. So here I have a slope that is neither parallel nor perpendicular. It's just sort of slashing through, which is more or less what a transversal does. So this would be satisfactory for the project of showing I have a pair of parallels, I have a pair of perpendicular lines, and I have a line that crosses through a couple others, and it does so at a non-90 degree angle. All right, hope this helps.